For new pilots making their first nighttime approach to landing, when the runway comes into sight or when they see the runway, it can easily appear as a complex and confusing collection of different lights with different colors. Knowing their configuration, spacing, color, and purpose has the power to bring clarity to the confusion and to train our eyes to pick out and understand what we are seeing as we make a nighttime approach to landing. So, colleagues, let's ask a question from ourselves: how to become confident in nighttime landings? The answer for this question, most especially for the new pilots, is that new pilots can become confident in nighttime landings with experience and familiarity with the airports and lighting systems. Besides, all new pilots should have regular practice, review, and study of the charts and procedures, which will help them safely navigate low visibility conditions. So let's start our journey through each type of the runway lighting system and details. When landing or taking off at night, it's important for the pilots to have a visual guide to the width of the runway. We should know how much wide the runway is, or are we approaching to the edge of the runway during takeoff or landing roll or not. Runway Age Lights are there to help us, and they are a series of white lights positioned in a row on either side of the runway, in fact left and right. Runway Age Lights are classified as low, medium, and high intensity. Among these intensities, the medium and high are adjustable based on the visibility conditions by the control tower or by the pilot request. The distance between each individual runway age light in a medium and high intensity runway lighting system should not be more than 200 feet. But at intersections between a runway and a taxiway or another runway, this distance can be increased to 400 feet. Runway age lights are not wide all the way from the beginning to the end of the runway, and there is going to be change of the color. At last 2,000 feet of the runway or half the runway length, the color of the lights will change from white to yellow, but when we look at the lights from the opposite side, they will all look white. Now, for the runways shorter than 4,000 feet, so this will be has an additional visual indicator that the pilot is nearing end of the runway. Besides the runway age lighting, it's very important to have a visual indication of the start and end of the runway, easily to say during approach to know the start of the runway, and during takeoff to know end of the runway. End of the runway is marked with runway end lights, and the second name for the runway end lights is the runway threshold identification lights. And these are a row of lights that extends all the way across the runway wide at either end. From the approach side of the runway, the lights all appear green. So this lets the pilots to know that they are at the end of the runway with the full length of the runway in front of them. What about from the opposite side? From the opposite side, the lights appear in red, and this informs the pilots that they are approaching the departure end of the runway, and now the entire runway is behind them. ICAO identifies these as a runway threshold identification lights, and they are installed to provide a rapid and positive indication of the approach and of a particular runway. The system consists of a pair of synchronized flashing lights located laterally on either side of the runway threshold. These lights can either be omnidirectional or non-directional, and they face towards the approach side of the runway. These lights are effective for identification of a runway surrounded by other lights or a runway which lacks contrast with the surrounding terrain, or to identify a runway during reduced visibility. The runway threshold identification lights should be located symmetrically about the runway center line, in line with the threshold, and approximately 10 meters away from the runway edge lights. Runway threshold identification lights should be flashing white lights with a flash frequency between 60 and 120 per minute. For precision instrument runways at larger airports, runway centerline lights installed. These lights help pilots keep their aircraft aligned during takeoff and landing. The lights are spaced 50 feet intervals down the length of the runway. These lights are white from the beginning of the runway until the last 3,000 feet of the runway. At this point, they alternate red and white for the 2,000 feet to warn the pilot that end of the runway is approaching. For the last 1,000 feet of the runway, the lights all change color to red. Runway centerline lights is a requirement for the Category 2, Category 3, and some of the Category 1 instrument runways. Approach lighting system, or ALS, help pilots transition from instrument to visual flight when landing. These lights guide the pilots towards the runway. Mostly in poor weather, it's quite normal for the pilots to see the approach lights before they spot the runway. Approach lights start at the landing threshold, and in most precision instrument runways, they extend 2,400 feet up to 3,000 feet, and non-precision approach runways, the lights extend from 1,400 feet up to 1,500 feet. In some approach lighting systems, sequence flashing lights is also installed, and the sequence flashing lights appear to the pilot as a ball of the light traveling towards the runway at a rate of twice per second. Approach lights comes with different configurations, and the most basic approach lighting system features a series of 17 white lights in a cross formation. This type of lighting is common at regional airports, but most large international airports, they use a more complex feature of the lights. They include the yellow and red lights together with the white lights in the approach lighting system of the runways. Visual approach slope indicator is a system of lights that provides visual descent guidance. Mostly VASI lights are visible from 3 to 5 miles during the day and 20 or more than 20 miles during the night. VASI installations consist of either 2 bars or 3 bars. The 2-bar VASI consists of a near bar and a far bar, and they consist of 2 to 4 or 12 light units. The 2 or 4 bar VASI is mostly located at the left side of the runway, and the 12 bar VASI is located both at left and right sides of the runway. Remember, the 2 bar VASI is always and normally set to 3 degrees. The three-bar VASI consists of a near bar, a middle bar, and a far bar. And they provide two visual glide paths, the lower and the upper. The lower glide path uses the near and the middle bars and is normally set at 3 degrees. But the upper glide path uses the middle bar and the far bar and is usually 1/4 degrees higher. The upper glide path is usually used by high cockpit aircraft like Boeing 747, but they allow them to cross the threshold at correct height. VASIs are red and white lights. Mostly upper part of the beam is white and the lower part of the beam is red. When below the glide path, both near and far bars become red. When the far bar is red and the near bar is white, we are on the glide path on 3 degrees. But when both near and far bars are white, we are above the glide path. What about a 3-bar VASI? In a 3-bar VASI, the condition is a little bit confusing, but very easy to know and remember. In a 3-bar VASI, when all bars are red, we are below both glide paths, lower and upper. But when the far and middle bars are red and the near bar is white, we are on the lower glide path. When the far bar is red and the middle and near bars are white, we are on the upper glide path. And when all bars are white, we are above both glide paths, lower and upper. A very simple way to remember is white over white, we are high. Red over white, we are all right. Red over red, we are dead. The precision approach path indicator works same as VASI. PAPI provides more accurate glide path reading than VASI. PAPI consists of a row of 2 to 4 light units, mostly located at the left side of the runway. And they are also set to 3 degrees glide path. To read PAPI with 3 degrees glide slope, the technique is very easy. So what's the technique? If all 4 bars are white, we are high at approximately 3.5 degrees from the 3 degrees glide path. At 3 white and 1 red, we are slightly high at approximately 3.2 degrees. But if 2 white and 2 red, we are on the glide slope, exactly 3 degrees. If it is 1 white and 3 red, we are slightly below the glide at approximately 2.8 degrees. But if all bars are red now, or our lights are red, now we are too low, approximately 2.5 degrees below the glide. PAPIs are also visible from 3 to 5 miles during the day and more than 20 miles or 20 miles during the night. Let's think what could happen if runway and taxiway lights were the same. Difficult. Pilots would have tough time telling one from the other. To prevent confusion, taxiway lighting system uses different colors than the runway lighting system. Taxiway Age Lights are blue and center line lights are green. The taxiway center line lead on and lead off lights help to get the aircraft on and off the runway. They use alternating green and yellow lights, and when approaching a runway from a taxiway, the center line lights will be all yellow. This way, the lights alert the pilots that they are entering the runway environment. Touchdown zone lights highlight the touchdown zone. So mostly on precision approach runways, you can see the touchdown zone lights. They overlay the touchdown zone pavement markings, and these lights provide pilots with a visual aiming point at night. Aircraft must touch down within this area to ensure they have enough distance to stop. Touchdown zone lights consist of two rows of white light bars on either side of the runway center line. The lights start at 100 feet behind the landing threshold and extend 3,000 feet down the runway or to the runway midpoint, whichever is less. It's mostly common at some airports that they displace the threshold due to safety or operational reasons. To easily identify and point the displayed threshold, a lighting system is installed and used. Display threshold lights consist of a row of red Age lights running parallel along each side of the runway, along with a group of 3 red lights to the left and 3 red lights to the right of the runway center line, similar to the configuration of the touchdown zone lights. The center line of a display threshold lighting system is marked with a row of white lights. The red Age lights signal that the area is not suitable for landing, although it can be used for takeoffs. Thanks colleagues for watching the presentation till now, and at the end I would like to focus on pilot control lighting, and we will see how a pilot can control the runway lights without contacting the tower. Some airports without control tower may use a pilot controlled lighting system. So this system can provide cost savings by means of decreased electrical costs and is designed to be radio activated by the pilot within 5 miles of the airport. Pilots can turn on the lights and select the preferred illumination intensity by all specific keying of the microphone button. Lights that are activated include runway lights and potentially VASI, PIPI, runway end identifier lights, and at some airports the taxiway lights. If pilots desire to use the pilot control lighting system, they should make sure to look up the proper radio frequency as part of the pre-flight preparation. It's also important to know and remember that pilot control lighting systems turn off automatically 15 minutes after activation, so be sure you have completed the landing prior to the cutoff. Thanks much colleagues for watching the video presentation, and I would like to thank you each individually for your messages and supports, and besides all, special thanks to my CPL students for whom I was serving as an online instructor for the nice gifts sent to me from long distances down to Kabul, Afghanistan. I congratulate you all for your achievement and wish you all the best in your next stages of the training. Thank you.